Okay. Yeah, I already did a self introduction before, so I try to be efficient. So we are in this talk we are trying to explain water knowledge graph and our latest development with implementation of GeoSPARQL standard inside. So I'm from Italy. So I'm working both in the research group and in the company. So first of all, what do you mean by water knowledge graph? Or this term has actually already been around not so long, but in the research community, initially has been called ontology-based data access for decades. But since around 2 years ago, we started to rebrand it as water knowledge graph because I believe that water knowledge graph will be probably more accessible by our community. So what we are working here is that we have normally when we deal with databases, some data sources, we know that we don't. For many of us, we don't really like these data sources because there is no semanticalized. What we want is that we actually want to access the data through ontology or through some vocabularies, with some water knowledge graph. For water knowledge graph, therefore, we have been studying this for 10 years to try to see how we can expose a database as a knowledge graph. And what's missing in between the knowledge graph or ontology and the data source is so-called mapping. So what we do is that we use declarative mapping so that we can populate the ontology instance using our data sources. In this way, it greatly simplifies access to the information in the data sources and frees end user to know the precise structure of the information sources. And this is so-called virtual because we don't materialize the data from the data source to the triple. What we do is that we do a so-called query rewriting. And this means when the user is asking a query, a SPARQL query specifically to the ontology, what we do is that we first rewrite the query. We write input SPARQL query into another SPARQL query over the ontology. So this rewriting step is used for implementing the reasoning step. So we support all reasoning, like hierarchy. For instance, the second step conceptually is called unfolding. So in the unfolding step, we unfold the query from the we unfold the SPARQL query to a SQL query over the data sources. To the data sources, so that the SQL query can be evaluated over the data source directly. Then the answer is a relational answer, can be some small massage. We can return it back as ontological answer and eventually back to the user. So this whole loop is transparent to the user. The user do not see this query rewriting step. What he sees that is just beginning. He send a query to the knowledge graph and he gets the answer, and the system taking care of this query transformation step. So this has some advantage when you don't want to move your data. There are many cases that you want to put your data inside your data sources, but you still want to have a more convenient view of the data. This is where our approach, our system can help. So this approach has been implemented in the system Ontop. We have been working this for 10 years already. It is initially developed at the Free University of Bozen-Bolzano here. And it's compliant with all the relevant semantic web standards like RDF, RDFS, AutoQL, R2ML, SPARQL, and GeoSPARQL recently. We support all the major relational databases like Oracle, DB2, Microsoft SQL Server, PostgreSQL, also with the PostGIS extension, MySQL, Dremio, Denodo Extreme, and so on. The system is released under a very permissive Apache 2 license. It's open source. You can use it whatever you want. Since 2 years ago, we started our own company. It's called Ontopic. It is the first university spin-off of our university. And through this spin-off, we offer commercial support to the system, also develop other tools. Recently, Ontop has also been shipped together with GraphDB by Ontotext in their recent version. on GraphDB. So the system has been used in quite some use cases. Looking at the download number is 40K in the past years. Well, I believe compared with Jena, this number is still rather small, but it's already a number we are quite happy with. So, and also we see the number is steadily growing. So talking about GeoSPARQL support in Ontop, actually we have been already working on GeoSPARQL support since many years. We have, during a project we are working on, this during a European project we are working on, this was already 8 years ago, maybe 7-8 years ago. So we started already to do some proof of concept to see how we can support GeoSPARQL inside Ontop, and we made a proof of concept. It was based on old version on top. We have made a fork on top, did some modification, but unfortunately that version has not been merged back due to some changes in the code. It's not that good, but we learned a lot. From there, we learned how to implement GeoSPARQL functions by translating them to suitable SQL counterparts. And this techniques has been also documented in a journal paper we published. This is Ontop spatial on top of geospatial databases. It's if you are interested in this, you can understand the techniques behind the implementation. However, as I said, the proof of concept was okay, but it's based on older version on top and has never been brought into the main release. So this is a big problem. And since last year, we started the effort of re-implementing GeoSPARQL properly inside Ontop. So it's an effort of 1 year. Now we are finally going to release it. And as you can see, the release date is going to be the end of this week, which means in 2 or 3 days. So the development is already done. We are just doing some very last steps, so packaging and check everything's fine. And we have good compliance with GeoSPARQL. How good it is, we still need to do more tests. And in particular, now I see this GeoSPARQL compliance benchmark is something we should definitely look into it to have a more fine-grained understanding how compliant we are with GeoSPARQL. So roughly speaking, we are good with like call components, topology vocabulary extension, we are all good. For geometry extension, currently we only support WKT, but not GML. The reason is simple, we don't have a use case for GML yet. That's why we did not really study that part. And we also support geometry topology extension. Query ret extension is not part of this release yet. It is planned for future release. Actually, in the old implementation, we had already tried the query ret extension, so we know how to do it. It's just we did not have enough time to redo it properly. Okay, so I'll give you a quick example how this thing works. So for instance, let's take a table with two rows about two cities, Bolzano, Milano. There are 2 small cities here. And when we create, when we talk about the water knowledge graph, we need to populate this knowledge graph from the database. So this is done through mapping. So a mapping is something like this. So it has 2 parts, the target part and source part. The source part is a SQL query over the database. So here, for instance, we can retrieve ID and geometry from the cities table. In the target part, we have it's a template of triples. So we can use ID to construct geometry, and we can also use the geom column to create a WKT literal out of it. As you can see, we can put the CRS inside. Now we can ask some simple SPARQL queries. So here, for instance, I can ask SPARQL query to compute the distance between these 2 cities, 1, 2, using with the unit meter. And what we do is that we will simply translate this GeoSPARQL query into a SQL query with the proper geospatial functions. In this case, for instance, the input unit is meter, we know, because of this SRID. And we also know what we expect is also meter. Then we know in this case, we can just use the standard ST distance function. Sometimes it's a bit more involved. For instance, we have latitude and longitude, we will not be able to, we are not going to translate into st distance, but we will translate to st distance sphere because we know these are the coordinates on a sphere, and we can use a dedicated function from PostGIS as well to st distance sphere. Also, we have to very carefully analyze all different possibilities of combination of s.r.l units in order to get correct answers. Okay, so this Ontop system and also its GeoSPARQL extension has been used in quite a large number of use cases. For instance, in some maritime security domain, and we are also working on a project called Open Data Hub to publish local tourism data. And there's the linked geodata project, it's a famous one. We also do some center data analysis. We have published the survey, it's already 2 years ago, covering quite some use cases. And we are very proud that our survey has been also used as a main reference in the recent ODC white paper for use cases. So now I will just use the last 2 minutes to present one concrete use case, which is the linked geodata project. Linked geodata project it's actually not really our project, but we see that we have the good opportunity to contribute to it. Linked geodata project is one of the most important geospatial knowledge graph. It converts OpenStreetMap data to RDF. The current way of using linked geodata is mostly to get a dump. So we can use dump, RDF dump to do some analysis. But we know that this is not scalable, also because it's not very flexible. Because OSM data is updated constantly. We cannot publish data dumps every day. We don't even have enough hard disk to store such dump. Therefore, we want to have a much more flexible, lightweight way to manage this infrastructure. So what we did is that together with our colleagues in Leipzig, we have tried to deploy Ontop over the OSM database so that we can offer a SPARQL endpoint over OSI. It's still work in progress, but we have already got some very promising results. And the next version of linked geodata will be based on Ontop. So for instance, what you can do with this interface, you can ask some physics example database with the data from Oracle. For instance, here we can ask queries like give me university and give me the restaurants close to this university within a distance of 200 meters. And also to illustrate, also create a buffer of 200 meters, draw as a circle here. Yes, that's it. So this is my presentation. If you are interested, there are a few links you might want to follow, and I'm happy to answer questions.
Very good. Thank you very much for this presentation, Guohui. While Beza gets ready in the background to prepare her presentation, we may take 1 or 2 questions for you from the audience.
Yeah, hi, Marco, Monica. Yeah, I have a question.
Very good.
Hi, thanks for the presentation. So do you have any use case through your company Ontopic where you've tried to connect to Elasticsearch either through the mapping layer or through Dremio, and if you've had any successes? Because that's our current use case that we want to try and test out, but because Ontop doesn't support Elastic directly, we did not have much success going through Dremio, and I was wondering if you were investigating this.
Okay, so we never work with Elasticsearch directly, but as you already mentioned Dremio. So we in Ontop version 4.1, which are going to release next days, 3 days. We have official support to Dremio. So through that, you can also access Elasticsearch.
Okay.
If you have any question, open issue, or contact us, we will be happy to fix it.
Okay, thank you.